Okay, so today we're going to talk about moles and what moles are. So basically, when I'm talking about 1 dozen of eggs, it's really easy to understand that I mean 12 eggs. So likewise, as scientists and chemists are always dealing with a huge number of atoms or molecules, so it's easier for them to create something that's called moles. So basically, what it means is if I'm saying that I have 1 mole of eggs, I basically mean I have 6.022 times 10 to the power 23 eggs. So basically, mole is just like what you would use for dozen. Mole is just, it defines a number that you have this much of that stuff. So likewise, if I'm saying I have 1 mole of pens, I have 6.022 times 10 to the power 23 pens. So you get the idea. So this is basically the new definition of moles. So basically, this is the new definition. There used to be an old definition that's not used anymore. So we will not get into how they figured this out. Maybe I will probably in the future in a different video, but you do not require to know how they figured out the Avogadro. Oh, by the way, this number is called the Avogadro's number. So I'll just mention that. So this number here is called the Avogadro's number. So you really need to memorize this number. So we'll talk about how scientists figured out the Avogadro's number maybe in the future, but it's not required for your O&L levels. And I try to keep these lessons in this channel pretty straightforward and easy to understand and simple. So in O and A levels, you basically need 3 formulas to calculate moles. And they are, the first one is moles is equals to mass divided by molar mass. Okay, so this mass needs to be in grams, and the unit of molar mass is gram per moles. You don't need to worry about the unit of gram per moles because molar mass in the periodic table is given in grams per mole. So, but make sure that your mass that you use here is in grams. The reason is, as you're calculating moles, you want the final unit to be MOL, mole. So in this structure, if you take say kilogram on top, whatever the unit is, I'm not getting into that. I'm just talking about the unit. Whatever the values, I don't care. I'm talking about the unit. So if you have kilograms here, and the molar mass from the periodic table is in grams per mole, the units will not cancel out. So this doesn't work. So this wouldn't work. So what you need is, the mass to be in grams, and the molar mass is always in grams per mole in the periodic table. So the grams would cancel out, and if you should know from, it's just simple mathematics that the denominator of the denominator is going to become the numerator. So the unit then becomes moles. So that's that. So what we're going to do is we're going to do probably a simple calculation to figure out the mole of something. Say for example, I want to find the number of moles in 5 grams of sodium. So what I'm going to do is I'm going to use formula number 1, as I know the moles, as I know the mass. So moles is equals to the mass, which is 5 grams. And then I'm going to go to the periodic table. So I have the periodic table down here. And in the periodic table, the number at the bottom is the atomic number, and the number at the top is the mass number, or the molar mass that we're talking about. So we go to sodium, we can see that the atomic number of sodium is 11, and its mass is 23. So this is the mass. The one at the top is the mass. This is the mass. This is what I'm talking about. So we're going to go here, and we're going to put 23 grams per mole. And we know that the units, grams cancel out. So you have 5 by 23 moles of sodium in 5 grams of sodium. So I'm not going to go and solve this out. I'm just going to leave it like that. So if you have a calculator, you can go and figure the value out. Okay, now let's try another one. Okay, so if we have a compound that has more than one atom, like the previous example we just had sodium. So if we have something that has something more complicated, such as sodium hydroxide, say. So the way we're going to figure out the molar mass of sodium hydroxide, so if I want to figure out the molar mass of sodium hydroxide, what I'm going to do is I'm going to find out the molar mass of sodium, then I'm going to add the molar mass of oxygen, then I'm going to add the molar mass of hydrogen to it. That's the molar mass of the whole molecule of sodium hydroxide. So I'm going to go to the periodic table again. I already know that sodium is 23, and then I'm going to go to oxygen. I know that oxygen is 16, and hydrogen is 1. Okay. So one thing I'd like to mention is you can see that the atomic numbers at the bottom are like whole numbers, okay, integers. But the mass numbers are in decimals, right? So why are the mass numbers like that? So we're going to talk about this later on, not today, but later on. Yeah. Okay. So let's get back here. So the molar mass of sodium is going to be the molar mass of sodium. So the molar mass of sodium hydroxide is going to be the molar mass of sodium, which is 23, plus the molar mass of oxygen, which is 16, plus the molar mass of hydrogen, which is 1. So we have 40. Okay, so this is, like I said, this is in grams per mole. So if you were to find the number of moles in, say, 2 grams of NaOH, the way you would do it is, this is the mass, 2 grams of NaOH divided by the molar mass of NaOH, which is 40 grams per mole. Grams cancel out. Simplify it, 21. So you basically have 1 over 20 moles of NaOH. Is that simple? Okay. So now we talked about this. Maybe we can look at something a little bit more complicated. Okay, let's talk about CaCO3. So I want to find the number of moles present in 10 grams of CaCO3. So the first thing I'm going to do is I'm going to find the molar mass of calcium carbonate. The way I do it is I add the molar mass of calcium. So go to the periodic table again. Calcium is 40. So 40 plus, and then I have carbon. So I go to the periodic table again. I find out that the molar mass of carbon is 12 plus. Then I have 3 oxygens. So I go to the periodic table again. I find out that oxygen's molar mass is 16, but I have 3 of them. So what I'm gonna do, so this looks like 160, but it's not. I'm really not good at writing on this tablet. Okay. So I know the mass. So I know the mass of calcium carbonate. I know the molar mass of calcium carbonate. So now it's easy. So moles of 10 grams CaCO3 is going to be the mass divided by the molar mass. So mass is grams. The molar mass is 100 grams per mole. Grams cancel out. Simplify this. This is 1/10. So it's like 0.1. Anyway, so I'll just leave it in the fraction. So 1/10 moles of CaCO3. So that's how we're going to calculate the moles using the first method. At your level, you're only going to have the concentration in mole per dm cube. So always remember to convert your volume to the unit of volume to dm cubes. So do not miss that. So we can do a calculation here. Say I have 100 cm cube of let's erase that. So I have 100 cm cube of 0.1 mole per dm cube HCl solution. HCl solution. So how do I figure out the moles of this? That's pretty. So we're gonna use that formula. The formula is moles is equals to volume. So as the concentration is in mole per dm cube, my volume needs to be in dm cube. Volume in dm cube times concentration in mole per dm cube. Okay. So my volume is 100. So I don't know if you know this. So whenever you're converting the volume from cm cube to dm cube, you have to divide that value by 1000. So I have 100 cm cube. So if I want to convert it into dm cube, I have to divide 100 divided by 1000 to make it dm cube. So my volume is going to be 100 divided by, so I'll change the color for the conversion. So this is for the conversion. 1000 divided by 1000, so this becomes dm cube times my concentration was in 0.1 mole per dm cube. So this basically means that dm cube is at the bottom. So this dm cube and this dm cube would cancel out. So let's check the value. So it's going to be 0.01. 0.01 moles of HCl is present in 100 cm cube of 0.1 mole per dm cube solution. So this is the final answer. So we can probably do another one. Okay. So let's say that we have let's say that we have 2 dm cube of 1 mole per dm cube in a OH solution. So we're going to figure out the moles. So the volume is already in dm cube, so we don't need to do anything. And the concentration is in mole per dm cube, so we're all set. So we're just going to put them into the formula. So the moles is equal to volume times concentration. So my volume is 2 dm cube. My concentration is 1 mole per dm cube. The dm cubes are going to cancel out, and my mole is going to be 2 mole. So that's that. That's pretty straightforward. So far we've talked about 2 formulas that we use in O and A levels. The first one was this one. The first one was this one. This is mass by molar mass. The second one is this one. Which is volume times concentration. Now we're going to talk about the third kind. Let me use green here. Okay. The third kind is mostly used for gases, and that is moles equals to the volume of gas. It's only used for gases actually, divided by molar volume. Okay. So before we go any further and do any calculation, we need to talk about what molar volume is. So molar volume by definition is, okay, so molar volume is basically the molar volume is basically the volume 1 mole of any gas occupies at a specific condition. So this is a very important bit of information. What I mean by a specific condition is if you go to a different temperature, different pressure, this molar volume is going to change. That same 1 mole of that particular gas is going to occupy a different volume at different temperature and different pressure. So at room temperature and pressure, at RTP, at room temperature and pressure, which is 25 degrees Celsius and 1 atm of pressure, this molar volume, this value, the molar volume is a constant. This is 24,000 cm cube per mole of gas. So if you do the unit conversion, this can be written as 24 dm cube per mole of that gas. So this is strictly at 25 degrees Celsius and 1 atm. This value only works at these conditions. So if you go to a different value, these values are going to change. So in the question paper, be it Cambridge, be it Pearson, in the question paper, if they do not give you a different, if they do not give you a value for the molar volume, you're always going to assume that it's at room temperature and pressure, and you can use these two values here. So if the condition is different, they are supposed to give you the molar volume at that particular condition. So if the condition is different and they give you a molar volume, use that. If they do not give you any molar volume, use these two values. You need to memorize this. Okay. So now let's do a calculation. So this was the formula. Volume of gas divided by molar volume. So let's see here. Let's see if our units work out. The volume of, if the molar volume is 24,000 cm cube per mole, and my volume is in cm cube, whatever the volume is, the cm cube is going to cancel out, mole is going to go to the top, and the final unit is going to be whatever, x divided by 24,000 moles, if this was x cm cube. So you get the idea. But if your volume is in dm cube, it's better that you use, if your volume was in dm cube, say y dm cube. It's better you use 24 dm cube per mole so that the dm cube was cancelled out and you would be left with y by 24 moles. Okay. So let's do a problem here. Say we want to find the moles of CO2 present in, say, 10 cm cube of CO2. So we're going to use the third formula, which one is moles is equals to volume of gas divided by molar volume, which is, so we're going to assume RTP, okay, because conditions are not, they didn't specify anything, right? So molar volume. So volume is going to be 10 cm cube, and the molar volume is going to be for the cm cube 1, 24, here you can see the 24,000 cm cube per mole. So this is 24,000 cm cube per mole. So my cm cube is going to cancel out. This one's going to be 1 by 2,400 moles of CO2. So that's how you do it. It's that straightforward. And if the volume is given in dm cube, say I have 1 dm cube of SO2. So again, moles equals to volume divided by molar volume. So as this one is in dm cube, it would be smarter for me to use the dm cube one. So dm cube is going to cancel out. I would have 1 over 24 mole of SO2. So that's basically it for mole calculation in O and L levels. So these are the three formulas. The first one is this one. The second one is this one, volume into concentration, and the third one is this one. So you basically need to know these three formulas. If you know these, you're good. You can do anything. And always remember that your units always cancel out and you always end up with moles. That's all you need to know. So that's that.